All right, welcome back. Welcome back. Day 13. Let me turn this down a little bit. Hello, everybody. Welcome back. Day 13. These numbers still feel very small to me, not gonna lie, but I'm just working on willpower right now. I think I'm giving myself some good exercise and discipline that I've been needing for a minute. But yeah, even though the numbers still feel small to me, because there's other things I can kind of other milestones I can celebrate. I guess that's the most straightforward way to say it. That's helping me along. I know because I've done this before, especially with the live streams, that eventually once I get far enough along, it'll start to feel more like this is just a normal part of my life. But right now, it's more like this is a new interruptive thing that, I'm just doing my best to make sure I'm here every day. But that's kind of how it starts. So, um, tonight, I'm excited because, as one of those milestones, I would say, I've been waiting to deploy, like get it to the model deployment. What was that, like a couple days ago? Was it earlier this week? I thought I was going to start. I wanted to try model deployment as a solution to having a long training time frame whenever I am actually in my coding sessions. So I felt like because it takes so long for my models to train, at least if I would deploy them, you know, then when it takes me a couple days or, basically a week to work through the material in my book, I'll be able to, just use the deployed model and kind of have them already at the ready, basically. Just train them once and then I can use them. But yeah, let's see. It was actually because, of course, I can tell from my log, right? I'm trying to. Oh, here. Okay, so it was actually on Monday. Yeah, this was Monday when I thought I was about to get into model deployment. But then when I looked in, I was like, well, let me see what do they have on deployment. It actually already it was like literally the next chapter is deployment. So that's why I just decided to hold out. So let's see. Yesterday, um, I finally finished chapter one. Yay. Okay. So I finished reading chapter one yesterday, and then today, um, I'm going to focus on deployments and looking forward to trying some newer ML tools that I've been eyeing for a minute. Okay, so that's what I'm doing today. Mm-mm-mm. So what I'll go ahead and I'm going to go ahead and save this and push this so I can get my commit in on the 20th, even though technically I guess my commit from yesterday was on the 20th. This mic is in the way. Um, all right, push. Okay, so let's go ahead and minimize that. This is just some random documentation I was reading through before when I was first looking at the new examples. Shadowless, welcome in. Had to skip one of the models in chapter 1 because it was taking too long to train. Yeah, it was that was, I that happened to me multiple days in a row. So, like, especially since I'm doing it like on the stream and everything, it was kind of weird because it was like as soon as I would start the training like at the beginning of my streaming session, and it would take at least over an hour and a half. And I don't know, I just had an impression that like at least the beginning examples wouldn't take as long. And I mean, that's not a long time to train. I will, for the record, an hour and a half to train like basically a state of the art model. At least with like the state of the art, architecture is not that's not a long time, but it's inconvenient for learning. At least it was inconvenient for me. So yeah, it was Monday, and I was like, oh, I'm gonna learn about deployment so I could train the models and just be able to um, use them whenever I got to that point in the code. But when I went to look and see exactly what information did they have on deployment and how they were going to have us doing it, I realized it's literally chapter 2. So that is where we are picking up today. And so I'm back to videos because, each chapter or each lesson has a video and then the corresponding chapter in the Fast AI book. So I did make some plans. I minimized it, but where is it? I did make some plans around projects though. So once I have my deployment all set up, then my workflow and everything, then I'll come back to my examples from chapter 1 because I want to do some basic examples from the code snippets they gave us in chapter 1. So the ones I called a lab, I said I would just kind of adapt those to another data set probably. And then the mini project was the image classifier, and I had kind of came up with an idea I had for the image classifier. So I wanted to kind of put together my own data set, not something really complicated, but something simple. Because I think they only use like 6 images to train that model or something. So I was thinking about just, actually using my own images for that one. But then the project was the sentiment analysis, and sentiment analysis was already on my project board. It's actually been on my list for like a couple years now. So to do it for our stream chat. So not only would that be building or training and deploying the model, that will also be integrating it with the Twitch API, and that will also be displaying it as a overlay on the stream. And usually the overlays are just browser sources. So it'll probably be a little bit of front end work, maybe a little CSS, little animations. I don't know. We'll see. Or maybe like a JS visualization library or something. I don't know, because it needs to be something visual. Like it's supposed to be like a mood ring. So the color would change depending on the mood of the chat. So those are the ideas I have for those projects. So that's why I'm so excited about this part, because now I can start working on some projects, but it's all good. I'm glad, Shadowless, I'm glad you're able to get something out of getting into this course too. All right, so Hugging Face. I'm trying to figure out, how did I even find Hugging Face? I don't know. I think I might have found them on LinkedIn, to be honest, because I was looking for like who hires like machine learning developer advocates. Very specific. And this was a little while back, and I'm pretty sure this was even before the whole little chat GPT craze or whatever. So I think I found them as like looking into that kind of or researching into like that kind of job role. And I heard about Gradio through Hugging Face. But I have set up like an account and everything. Matter of fact, because I don't think I'm signed in on this profile. Ooh, I don't even know what email address I use, to be honest. Here, let's do this. Let's just do this real quick because I don't know what email address I'm under. Probably my personal email, but anyways, I came across Hugging Face, and I have been I like seeing what they're doing, and there's like a lot of the open source models and things like that. What the heck is this? And then so they have the community side of things, but they also have spaces where you can do training, and I haven't tried any of that out yet. So actually, the reason why I'm doing the fast AI course right now is because the main course I really want to take is the NLP course from Hugging Face, but they did recommend that you have a deep learning course as a prerequisite. And one of the courses that they recommended was the fast AI course. So yeah, this is cool. How is the leaderboard determined though? Okay, so yeah, I just like, I don't know, I like how their community is. Um, and I wanted to try out the training tools that they have. So looks like that's exactly what we are going to be doing. So I'm just going to pretty much run the video for the second lesson today, probably take some notes, and maybe try to get some basic stuff set up if it's appropriate. I'm glad it's helpful. Yeah, because I mean, that's how it is, right? Like sometimes I mean, okay, don't get me wrong. There's complexity to it, right? It's machine learning, but at the same time, and this is something I've been harping on for years, ever since I started getting interested in machine learning. I just want a lot of developers to know like that isn't you if you don't want to like actually be a machine learning engineer, you don't want to, you know, like I want to do research and things like that. You don't want it to be your specialty. That's okay too. But we still need to know about the technologies, and there's a lot of tools that allows you to basically interact with machine learning the same way we interact with other libraries and frameworks that we're already used to. It's just the same. It's the same thing. It's the same thing. Like how many people implement their own like graph algorithms or search algorithms from scratch? There's definitely people out here that do that, but there's also developers that don't even know like data structures and algorithms, at least like deeply enough to be able to implement them independently. And it's the same thing here. So um it has come a long way even since I started getting interested in machine learning, because back in like probably 2017, 2018, TensorFlow was one of the best options you had as far as the different libraries. Um, but they had taken this approach where it was like, okay, let's abstract away, a lot of the specifics and just give you access to an API essentially. And since then, I think PyTorch has come and done more of that work. And also, fast AI is a very high level API that's built over PyTorch. So it's so many more tools now. And then now, of course, like back at first, you only had OpenAI and they were making APIs, but it wasn't open access on the APIs. So that was a challenge. And now it's like you have open source models and like all these, basically now we have these base models that we can have access to. So it's come a long way. You know, I'm excited about how things are going. Haven't touched calculus in almost 20 years. Yeah, I haven't it hasn't been 20 years, but it's been like more than 10 probably since I don't know when I took my last calculus class, but I mean, I am going to have to refresh on a lot of the math because I'm going back to school. It's been a long time since I took those classes, and even for the next program that I'm going into, I have to have calculus within the last 5 years, which is absolutely not the case. So I will be refreshing, but I still have learned that it's this top-down approach, exactly what they said in the first lesson, like taking that top-down approach. That's how I think that a lot of this material can be a lot more accessible, and I'm glad to see that that's kind of the structure that they're taking. So yeah, a lot of the points that they made in the first lesson, I highly agree with from the teaching perspective, because I believe that's, you know, one of our big gaps in academia compared to, you know, people that are able to go like the boot camp route or self-taught or whatever. Like you could start at the practitioner level and then you can get deeper into the weeds and learn more of the fundamentals and the theory behind everything. But most people don't latch on to theory because they don't understand the concepts and they don't have anything to apply it to when you start from the roots and then go up. Like if you just start trying to explain to me about all these different little roots and the soil around the roots, I'd probably be like, yes, sure, I'm never gonna know like why I need to understand this. But then if you show me the tree first and you know you show me the leaves that hang off the tree and everything, then maybe once you get down to talking about the roots, now I understand and I'm like, okay, so you know I care about how the bigger organism is affected. So getting into the weeds and learning like the nitty-gritty details actually has some type of context for it. So they're taking the same approach. So I'm like, even though I'm definitely trying to, like I said, I mean, I want to do research and I am getting back into school to pursue a PhD. So I even though I know I want to go down to the theory level, I'm not going to start at the theory level just because I've learned, you know, through experience that doesn't necessarily help out the most, because when you get too far into the theory too early, most of the time to me what happens is like you don't even know where to focus. It's not only do you not have context for it, but it's so many things that you're trying to learn at the same time. So if you start at the top and just kind of peel away the layers, it's easy to build on the concepts. So I really appreciate this course. The other resource that I know to look to is deeplearning.ai because I've followed them for a while as well. Like Andrew Ng and his team. So that's the specialization I'll probably end up doing. So let's get this ready to go. And for the record, for anybody else that finds it interesting, one of the playlists that I have saved under like the YouTube resources is, let's go to my channel. Hey, look, it's me. We can go to my channel from here. So one of the sections on the homepage where I refer to this playlist as well is inside the MLAI videos I recommend. So Practical Deep Learning for Coders 2022, that's this course. That's the playlist with all the videos. So, um, you can see their material is really good. All right, so it's an hour and 16 minutes. I'm just gonna try to power through the whole thing today, but we'll see how I feel. Cause yeah, your girl been trying to get some sleep this weekend. Um, so let's pause.
Everybody, welcome to listen to. Thanks for coming back. Uh, Slight change of environment here. We had a bit of a
All right, make this big.
administrative issue at our university. Somebody booked our room. Hi, everybody. Welcome to listen to. Thanks for coming back. Slight change of environment here. We had a bit of a administrative issue at our university. Somebody booked our room, so I'm doing this from the study at home. So sorry about the lack of decorations behind me. I'm actually really pumped about this lesson. It feels like going back to what things were like in the very early days, because we're doing like some really new, really cool stuff, which, stuff that hasn't really been in courses like this before. So I'm super excited. Um, so thanks a lot for coming back after lesson one, and I hope it's worth you coming back. I think you're going to love it. I'm really excited about this. Now remember
I'm gonna
that
get a hard
the
copy of the
course
book too.
goes with the book, so be sure that you're not following along in the book, because we're covering similar things
I
to
buy
the
books
introduction
and
to
I love
systematic
O'Reilly
history in the book
books.
as well. Remember, the
It's
book
kind of
is
interesting because I'm
entirely
like,
available for.
I didn't get that book. Hold on, I'll grab my book, the one that I have. Okay, so when I wanted to, it's like a little hot second, but when I wanted to start, I picked this book. Um, I don't know why I chose this one over the other option, but I kind I kind of wish I would have picked the Fast AI book. It's okay though. I think I'm gonna get a copy anyway because I would like to, have an actual physical copy. I'm that person. But I have been using I have been using the notebooks. They have this is what he's showing. They have a repository with all the information you need if you don't buy the book.
For free as well. You can go to the fast.ai Fastbook repo to see the notebooks, or through course.fast.ai. You can read it there, for example, through Colab. Um, and also remember that the book's got a lot of stuff that we didn't cover in the course, like, stuff I find pretty interesting about the history of neural networks, some of which has some really interesting personal stories, actually, as you'll read here. And at the end of each chapter, there is a quiz. And remember, it's not a bad idea before you watch the video to read the quiz. So if you want to read the chapter 2 quiz, and then come back, that's not a bad idea. And then make sure that you can do the quiz after you've watched the video and you've read chapter 2 of
Here,
the book.
let's do the quiz real quick because I think that he's right about that. Um, shoot, VS Code. because it'll be a good primer. It'll be a good primer. So I did read through the questions from chapter 1 yesterday. I felt pretty comfortable with, like, I would say 95% of them, maybe 94% of them. But I'm still going to go back and do like a more thorough review with them. Damn it, that's not the that's not the right repo. Okay, here it is. AIM fast that. Okay. So yeah, you can literally just clone the repository or fork it and clone your copy. So number 2 is production. So I'm not going to get into the notebook really, but I'm going to scroll to the bottom, and at the bottom of this notebook you can find the review questions for this chapter. I'm such a nerd because, like, this is so exciting to me. Oh, lots of questions. Okay. Provide an example. Oh, let me make it a little bit bigger. Okay. Thank you. I appreciate that notification. All right. Are you ready, computer? You struggling? It's okay. Okay, provide an example where the bare classification model might work poorly in production due to structural or style differences in the training data. Where do text models currently have a major deficiency? What are possible negative societal implications of text generation models? Oh, we are doing, is that what we are focused on this chapter? This is just, I don't know. I really like how this course is laid out. What are possible, okay, I read that one. In situations where a model might make mistakes and those mistakes could be harmful, what is a good alternative to automating a process? What kind of tabular data is deep learning particularly good at? What's a key downside of directly using a deep learning model for recommendation systems? What are the steps of the drivetrain approach? How do the steps of the drivetrain approach map to a recommendation system? Create an image recognition. Oh, I can't talk. Create an image recognition model using data you curate and deploy it to the web. Absolutely, positively, without a doubt. So that was already a part of the instructions for this chapter, to do the image recognizer. So that's perfect. That'll be our mini project. I feel like that same song always plays, and it is so loud. It's so much louder than the rest of them. Okay, so create an image recognition model using data you curate and deploy it to the web. So I'm already planning on doing that. And then what is data loaders? What 4 things do we need to tell fast AI to create data loaders? What does the splitter parameter do? Oh, what does the splitter parameter to data block do? How do we ensure a random split always gives the same validation set? I know that one, but I don't. It's in my notes though. To get a consistent data set. Okay, I'm not gonna focus on that, but I do remember reading about that in chapter 1 with the fast AI. What letters are often used to signify the independent and dependent variables? X and Y. What's the difference between the crop, pad, and squish resize approaches? When might you choose one over the others? What is data augmentation? Why is it needed? What is the difference between item transforms and batch transforms? What is a confusion matrix? What does export save? What is it called when you use a model for getting predictions instead of training? What are IPython widgets? When might you want to use CPU for deployment? When might GPU be better? What are the downsides of deploying your app to a server instead of to a client or edge device such as a phone or a PC? What are 3 examples of problems that could occur when rolling out a bare warning system in practice? What is out of domain data? What is domain shift? And what are the 3 steps in the deployment process? They literally say start a freaking blog. Okay, well, that's good. I know by the end of this chapter, we know what we're doing next, y'all. Okay, so that'll be our first. I'm like hella behind with the whole blog process right now, so that will be my focus. Okay, going back, going back, going back.
Something I didn't mention last week is there's also a very cool thing that Radek, who I mentioned last week, has written called aiquizzes.com, which is a site specifically for quizzes about the book. And it actually uses repetitive spaced learning techniques to make sure that you never forget.
Oh, nice.
So do check out aiquizzes.com. It's all brand new questions. They're different to the ones in the book. And they're really nicely curated and put together. So check out aiquizzes.com as well. Remember, as well as course.fast.ai, there's also forums.fast.ai. So course.fast.ai is where you want to go to get, links to all the notebooks and Kaggle stuff and all that stuff. You'll also find on forums.fast.ai, every lesson has an official topic, with all the information you'll need. Generally, there'll be a bit more info on the forums. We try to keep the course lean and mean, and the forums are a bit more detailed. So if you find, well, in this case, you'd want to look at the lesson 2 official topic, but here's the lesson 1 official topic so far. So from the lesson 1 official topic, already after just a few days since I recorded it, we haven't even launched the course, so it's just the people doing it live, there's already a lot of replies. And that can get pretty overwhelming. Be aware that there's a button at the bottom of my post that says summarize this topic. And if you hit that, then you'll just see the most upvoted replies. And that's a really good way to just make sure that you hit on the main stuff. So there's the button, and here's what it looks like after you hit it. You'll just get the upvoted stuff from fast AI legends like Sanyam and Tanishq. So hopefully you'll find that a useful way to use the forum. So one of the cool things about this week is I, as promised, put up the show us what you've made post, and already a lot of people have posted. I took this screenshot a few days ago. It's way above 39 replies already, if I remember correctly. I had a lot of trouble deciding which ones to share because they're all so good. So I've actually decided to kind of, went the easy route, and I just picked the first. So I'm just going to show you the first ones that were posted because they're all so good. So the very, very first one to be posted is a damaged car classifier. So that worked out pretty well, it looks like. And I really liked what Matt, the creator, said about this is that, wow, it's a bit uncomfortable to run this code I don't really understand yet, but I'm just doing it. And so I'm like, yeah, good on you, Matt, for just doing it. That's the way to get started. It's all going to make sense, don't worry. Very nice to see that the next one posted was actually a blog post in Fast Pages. Very nice to see. So just describing some stuff, some experiments that they ran over the week, and what did they find? Next one was the amazing beard detector, which, if I understand correctly, was mainly because it's very easy to get from bird to beard by just changing one letter to 2. And this is doing a very good job of finding gentlemen with beards. So very nice. And then this one is another level again. It's a whole in-production web app to classify food, which is kind of like extra credit. Apparently, we're up to 80 replies now in that thread. Thank you, Sanyan. Very cool.
Well, they got some baklava in there.
You know, obviously, so this was actually created by Suvash, who's been doing the courses for a few years now, I believe. And so, you know, one day you too might be able to create your very own web app and put it in production.
We are doing
when I
that
say one day,
like this week.
More specifically, today. I'm actually going to show you how to do this.
Yes, today, like
right
you
now.
said,
So
absolutely,
it's quite lucky
positively.
coincidence that Suvash put this up there, because it's exactly the topic that we're going to pick today. So how do we go about putting a model in production? Step one is well, you've kind of done step one, right? Step one is step 1, 2, 3, 4 is it's figure out what problem you want to solve, figure out how to find the data for it, gather some data, and so forth. So what's the kind of first step after you've got your data? The next step is data cleaning. And if you go to chapter 2 of the book, which I'm going to go ahead and open up now. So here is the book. So you can open it in Colab directly from the course, or if you've cloned it to your computer or whatever, you can do it there. So remember, course.fast.ai will run you through exactly how to run these notebooks. And so you can see chapter 2 is all about putting stuff in production. And so here is chapter 2. All right, and so remember, we hit Shift Enter to run cells, okay, to execute them. And so we're going to go to the part of the book where we start cleaning the data. So I'll click on Navigate.
Oh,
and we'll go
Navigate.
down here, Gathering Data.
Never use that. I literally never use that.
There we are. So we could do a quick bit of revision first. Now, by the way, I will mention, a lot of people ask me what are the little tricks I use for getting around Jupyter Notebook so quickly and easily. One of the really nice ones, as you'll see, is this Navigate menu, which actually doesn't appear by default.
Oh, okay.
So if you install something called Jupyter Notebook Extensions, and so you just pip install them, follow the instructions.
Okay, hold on. Hold on. What did he say?
And then restart Jupyter.
Notebook extension.
Obviously, this Colab already has a table of contents, by the way. So this is just if you're using something
never mind.
local, for example.
Wait, I don't.
Then you'll see here that this NB extensions thing will appear. And if you click on Table of Contents 2, that gives you this handy navigation bar. The other thing I really like is this one here called
Not me scrolling
headings.
when I can just do that.
And that's the one which gives me these nice little things here to close and open up.
Oh,
and actually, that's not
right
even
here.
the best part. The best part for me is if I hit right arrow, it goes to the end of a section. And if I hit left arrow, it goes to the start of a section. So it's like if I want to move around sections, I just press up, left, down, right, very handy. And if you hit left again when you're here, it'll close it up. Hit right again here, open it up. So that's collapsible headings. Anyway, a couple of really handy things. And we'll be talking a lot more about getting your notebook set up today in a moment. Okay, so one thing you'll notice is in the book, we use the Bing API for searching images. I've just gone ahead and replaced Bing with DDG because the Bing API requires getting an SDK key, which honestly, it's like the hardest thing in deep learning is figuring out the Bing Azure website and getting that sorted out. DDG doesn't. So it's basically exactly the same, and you can I'll share this notebook as well on the course website and the forum. But all I've basically done is I've replaced Bing with DDG and got rid of the key. So then, just like we did last week, we can search for things. And so in the book, we did a bear detector because at the time I wrote it, my then toddler was very interested in me helping identify teddy bears. And I certainly didn't want her accidentally cuddling a grizzly bear. So we show how we can search for grizzly bears, just like last week. Something that loops through grizzly bears, black bears, and teddy bears, just like last week. Get rid of the ones that failed, just like last week. And one thing a few people have asked on the forum is, how do I find out more information about basically any Python or fast.ai or PyTorch thing? There's a few tips here in the book. One is that if you put a double question mark next to any function name, you'll actually get the whole source code for it. And by the same token, if you put a single question mark, you'll get a brief little bit of information. If you've got nbdev installed, I think it's nbdev you need, then you can type doc, and that'll give you, perhaps most importantly, a link straight to the documentation, where you can find out more information, and generally there'll be examples as well. And also a link here to the source code if you want to, let's do that with a control. Okay, a link to the source code, and that way you can jump around. And notice that in GitHub, in the source code, you can click on things and jump to their definition. So it's kind of a nice way of skipping around to understand exactly what's going on. Okay, so lots of great ways of getting help. But what I promised you is that we're going to now clean the data. So I'm going to tell you something that you might find really surprising. Before you clean the data, you train a model. Now I know that's going to sound really backwards to what you've probably heard 1,000 times, which is that first you clean your data and then you train your model. But I'm going to show you something really amazing. First, we're going to train a model, and you'll see why in a moment. So to train a model, just like before, we use a data block to grab our data loaders. There's lots of information here in the book about what's going on here. There we go. And so then we can call show batch to see them as per usual. There's a little sidebar here in the book I'll quickly mention, which is about the different ways we can resize. I think we briefly mentioned it last week. We can squish. Last week I used a string. You can use a string or this kind of enum-like thing that we have. You can see with a squish, you can end up with some very thin bears, right? So this is the real size, the shape of the bear. Here it's become thin, but you can see now we've got all of its cubs. Are they called cubs? Yeah, bear cubs. So it's squished it to make sure we can see the whole picture. Same one here. This one was out of the picture. We squished it. This guy now looks weirdly thin, but we can see the whole thing. So that's squishing. Whereas this one here is cropping. It's cropped out just the center of the image, so we get a better aspect ratio, but we lose some stuff. This is so we can get square images. And the other approach is we can use pad. And so you can pad with various different things. If you pad with zeros, which is black, you can see here now we've got the whole image and the correct aspect ratio. So that's another way we can do it. And, different situations, result in different quality models. You can try them all. It doesn't normally make too big a difference, so I wouldn't worry about it too much. I'll tell you one, though, that is very interesting is random resized crop. So instead of saying resize, we can say random resized crop. And if we do that, you'll see we get a different bit of an image every time. So during the week, this week, somebody asked on the forum, I'm trying to, this is a really interesting idea, which it turned out worked slightly, was they wanted to recognize pictures of French and German texts. So obviously this is not the normal way you would do that, but just for a bit of an experiment, and I love experiments. So they had very big scans of documents, and they wanted to figure out whether it was French or German just by looking at images. And they said the pictures were too big, what should I do? I said use random resized crop, and that way you would grab different bits of the image. And this is very nice because you could run lots and lots of epochs and get slightly different pictures each time. So this is a very good technique. And this idea of getting different pictures each time from the same image is called data augmentation. And again, I'm not going to go into too much detail about data augmentation because it's in the book, but I'll just quickly point out here that if you use this thing called aug transforms, so augmentation transforms, and here I have multiplied them by 2, so I've made them super big so you can see them more easily. You can see that these teddies are getting turned and squished and warped and recolored and saturated, all this stuff to make every picture different. And generally speaking, if you're training for more than about 5 or 10 epochs, which you'll probably want to do most of the time, unless you've got a super easy problem to solve, you'll probably want to use random resized crop and these aug transforms. Don't put the multi-equals 2, just leave that empty. I'm just putting it there so you can see them more clearly. So I've got an interesting question here from Alex in our audience, which is this copying the image multiple times, doing something like this or something like this? And the answer is no, we're not copying the image. What happens is that image, so each epoch, every image gets read. And what happens here is kind of in memory, in RAM, the image is being warped, right? We're cropping it and recoloring it and so forth. So it's a real-time process that's happening during model training. So there's no copies being stored on your computer, but effectively it's almost like there's infinitely slightly different copies because that's what the model ends up seeing. So I hope that makes sense, Alex, and everybody else. So that's a great question. Okay, so we've got, we're going to use random resize crop, we're going to use augmentation transforms so that we can get a data loaders from that, and then we can go ahead and train our model. It takes about a minute. In this case, we only did 4 epochs of fine-tuning. We'll talk about why there's 5 here later in the course, but 4 main epochs of fine-tuning. So we probably didn't really need random resize crop and aug transforms because there's so few epochs, but if you want to run more epochs, this is a good approach. Under 3% error, that's good. Okay, so remember I said we're going to train a model before we clean. Okay, so let's go ahead and train it.
I'm still trying to figure out why that's a good idea. But I mean, I accept that he knows what he's talking about.
So while that's training, so it's running on my laptop, which only has a 4 gigabyte GPU. It's pretty basic, but it's enough to get started. While that's training, we'll take a look at the next one. So the first thing we're going to look at is the confusion matrix. And the confusion matrix is something that it only is meaningful for when your labels are categories, right? And what it says is what category errors are you making? And so this is showing that the model that we've got at this point, there were 2 times when there was actually a grizzly bear and it thought it was a black bear. And there was 2 times when there was actually a black bear and it thought it was a grizzly bear. And there was no times that it got teddies wrong, which makes sense, right? Because teddies do look quite different to both. In a lot of situations, when you look at this, it'll kind of give you a real sense of like, okay, well, what are the hard ones, right? So for example, if you use the pets data set that we quite often play with in the book and the course, this classification matrix for different breeds of pet, really shows you which ones are difficult to identify. And I've actually gone in and like read Wikipedia pages and pet breeding reports about how to identify these particular types because they're so difficult and even experts find it difficult. And one of the things I've learned from doing the course actually is black bears and grizzly bears are much harder to pick apart than I had realized. So I'm not even going to try. But I'll show you the really interesting thing we can do with this model is that now we've created this classification interpretation object, which we use for the confusion matrix. We can say plot top losses. We can say plot top losses. And this is very interesting. What it does is it tells us the places where the loss is the highest. Now, if you remember from the last lesson, the loss is that measurement of how good our model is that we take after each time we run through an item of data. A loss will be bad if we predict wrongly and we're very confident about that prediction. So here's an example where we predicted, here's the order here, prediction, actual, loss probability, where we predicted grizzly and it was actually a black. And we were 96% sure, our model was, that it's a grizzly. Now, I don't know enough about bears to know whether the model made a mistake or whether this actually is a picture of a grizzly bear. But so an expert would obviously go back and check those out, right? Now, you'll notice a couple here. It's got grizzly, grizzly, teddy, teddy. They're actually correct, right? So
But I
why is
wasn't
this
sure.
loss bad when it was correct? And the reason
The
is because it
model
wasn't
wasn't
very
sure.
confident.
Yeah.
It was only 66% confident, right? So here's a teddy. It's only 72% confident, right? So you can have a bad loss either by being
It was
wrong
confused
and
by the
confident,
eyebrows.
or being right and unconfident. Now, the reason that's really helpful is that now we can use something called the fast.ai image classifier cleaner to clean up the ones that are wrongly labeled in our data set. So when we use the image classifier cleaner, it actually runs our models. That's why we pass it learn, right? And I mentioned that I don't know much about black bears and grizzly bears, but I do know a lot about teddy bears. So I'll pick teddy bears. And if I click teddy bears, it's now showing me all the things in the training set, you can pick training or valid, that were marked as teddy bears. And here's what's really important. They're ordered by loss. So they're ordered by confidence, right? So I can scroll through just the first few and check they're correct, right? And oh, here's a mistake, right? So when I find one that was wrongly gathered, I can either put it, if it's in the wrong
Why is
category,
that so funny to me?
I can choose the correct category, or if it
It's
shouldn't
a
be there
cute
at all, I
dog.
click delete.
That's a
And I'll
nice
go ahead
feature,
and
though.
click delete, right? So I can see some reasons that some of these are hard. Like, for example, here's two teddies, which is just, I guess, confusing because it doesn't see that often. This one here is a bit weird looking. It looks almost like a wombat.
That's not really a teddy
This is an awful
bear.
lot of teddies. This one maybe is just a bit hard to see from the background, but these otherwise they look fine.
It's a stuffed bear. That'll make it a
So we
teddy
just look through
bear.
the first few. And if you don't see any problem or problems in the first few, you're probably fine. So that's cleaned up our training set. Let's clean up our validation set as well. So here's that one it had trouble with. I don't know why it had trouble with that one, but so be it.
I feel like you've never seen this movie before.
Okay, I'm not really sure that's a bear. So I'm just going to go ahead and
It's not a bear.
It's a teddy something. But, you know, it's a problem. Okay, that's not a teddy either. So you see the idea, right? So after we've done that, what that does is the cleaner has now stored a list of the ones that we changed and a list of the ones we deleted. So we can now go ahead and run this cell. And so that's going to go through a list of all of the indexes that we said to delete, and it will delete those files. And it'll go through all the ones we said to change.
I have never seen index
move them to a new folder.
Abbreviated like that.
There we go. Done. So this is like not just
I'll just
something
rather
that
see an
anyone wants.
eye.
It's
That's
just,
how I know
it's actually
index.
a really powerful technique that almost nobody knows about and uses, which is before you start data cleaning, always build a model to find out what things are difficult to recognize in your data, and to find the things that the model can help you find data problems. And then as you see them, you'll kind of say, okay, I see the kinds of problems we're having, and you might find better ways to gather the next data set, or you might find ways to kind of automate some of the cleaning and so forth. Okay, so that is data cleaning. And since I only have a 4 GB GPU, it's very important for me to close and halt because that will free up the memory. So it's important to know on your computer, your normal RAM doesn't really get filled up because if you use up too much RAM, what will happen is that instead your computer will start, it's called swapping, which is basically to save that RAM onto the hard disk to use it later. GPUs can't swap. GPUs, when they run out of RAM, that's it, you're done. So you need to make sure that you close any notebooks that are using the GPU that you're not using, and really only use one thing at a time on the GPU, otherwise you'll almost certainly run out of memory. So we've got the first few reds starting to appear, so remember to ask, and in terms of the yellows, it's important to know, as you watch the video, I'm not asking you to run all this code, okay? The idea is to kind of watch it and then go back and pause, as you go along, or you can just stop, try, stop, try. The approach I really like, and a lot of students really like for watching these videos, is to actually watch the entire thing without touching the keyboard to get a sense of what the video is about, and then go back to the start and watch it again and follow along. That way, at every point, you know what it is you're doing, you know what's going to happen next. That can actually save you some time.
I'm just
It's a bit of
doing like
an unusual way,
videos,
because obviously, like,
and then you might as well go
real
straight
life
to the book.
lectures, you can't do that. You can't rewind the professor and get them to say it again. But it's a good way to do it here. So now that we've cleaned our data, how are we going to put it into production? Well, in the book we use something called Voila, and it's pretty good. But there's actually something that I think most of you are probably going to find a lot more useful nowadays, which is something called Hugging Face Spaces. And there's a couple of things you can use with that. We're going to look at something called Gradio today. There isn't a chapter about this in the book, but that doesn't matter, because Tanishq Abraham, who's actually one of the TAs in the course, has written a fantastic blog post about really everything we're going to cover today. There's a link to that from the forum and from the course page. So this is like the equivalent of the chapter of the book, if you like. And I would be remiss if I didn't stop for a moment and call out Tanishq in a big way for two reasons. The first is he is one of the most helpful people in the fast.ai community. He's been around quite a few years, incredibly tenacious, thoughtful and patient, and also because I have this fantastic picture of him a few years ago with Conan when he was a famous child prodigy. So now you know what happens to famous child prodigies when they grow up. They became even more famous fast.ai community members and deep learning experts. So you should definitely check out this video of him telling jokes to Conan. I think he's still only 18 actually, so this is probably not that many years ago. So thank you very much, Tanishq, for all your help in the community, and sorry for embarrassing you with that picture of you as a 9-year-old. I'm not really. Okay, now the thing is, for doing Gradio and Hugging Face Spaces, well, it's easy enough to start. Okay, we start over here on the Hugging Face Spaces page, which we've linked to from the forum and the course. And we're going to put a model in production where we're going to take the model we trained, and we are going to basically copy it to this Hugging Face Spaces server and write a user interface for it. So let's go, create new space. Okay, so you can just go ahead and say, all right, so obviously you sign up, the whole thing's free. Basically everything I'm showing you in this entire course, you can do for free. That's the good news. Okay, so give it a name, just create something minimal. I always use the Apache license because it means other people can use your work really easily, but you don't have to worry too much about patents. As I say, there's a few different products you can use with it. We're going to use Gradio, also free. If you make it public, then you can share it, which is always a good idea when you're a student, particularly to really be building up that portfolio. Okay, so we're done. We've created a space. Now, what do we do next? Well, Spaces works through Git. Now, most software developers will be very familiar with Git. Some data scientists might not be. And so Git's a very, very useful tool. I'm not going to talk about it in detail, but let's kind of quickly learn about how to use it, right? Now, Git, you can use it through something called GitHub Desktop, which is actually pretty great. And even people who use Git through the console should probably be considering using GitHub Desktop as well, because some things are just much faster and easier in it. In fact, I was talking to my friend Hamill today, and I was like, oh, help, I've accidentally committed this 2 things by mistake. What's the easiest way to revert it? And he used to work at GitHub, and I thought he was going to have some fancy console command, and he was like, oh, you should use GitHub Desktop, and you can just click on it. I was like, oh, that's a great idea. So that's useful. But most of the time, we do use Git from the console, from the terminal. If you're a Linux user or a Mac user, you've already got a terminal. Very straightforward, no worries. If you're a Windows user, I've got good news. Nowadays, Windows has a terrific terminal. It's called Windows Terminal.
Thanks for the alert, Preacher. I'm doing good. I'm just happy to be at this point.
You see me
I'm ready to deploy something.
I'm actually using that.
I'm itching to
Windows
deploy
terminal.
something.
Works very well. God knows why you'd want it to with all these ridiculous colors, but there you go. Now, what do you want to be running inside your terminal? Obviously, if you're in Linux or Mac, you've already got a shell set up. In Windows, you almost certainly want to use Ubuntu. So Windows, believe it or not, can actually run a full Linux environment. And to do it is typing a single line, which is this. So if you go to just Google for WSL install, run PowerShell as administrator, paste that command, wait about 5 minutes, reboot, you're done. You now have a complete Linux environment. Now, one of the reasons I'm mentioning this is I'm going to show you how to do stuff on your own machine now. And so this is like going to a bit of an extra level of geekery, which some data scientists may be less familiar with. So, don't be worried about the terminal. I think you're going to find it really helpful and much less scary than you expect. I particularly say, like for me, I choose to use Windows, and that's because I get, all the nice Windows GUI apps, and I can draw on my screen and do presentations, and I have a complete Linux environment as well. And that Linux environment uses my GPU and everything. So for me, my first choice is to use Windows. My second choice, by not very much, really like it, would be to use Linux. Mac is a little bit harder, but it's still usable. So some things are a little bit trickier on Mac, but you should be fine. Okay, so whatever you've got, at this point you've now got a terminal available. And so in your terminal, one of the really nice things about using a terminal is you don't have to follow lots of instructions about click here, click here, click here. You just copy and paste things. So I'm just going to, you just copy this, and you go over to your terminal, and you paste it in, and you run it. And after you do that, you'll find that you've now got a directory. And so that new directory initially is empty, and they tell you, okay, go ahead and create a file with this in it. Okay, so how do you create a file with that in it when we're in here in our Linux environment on Windows or in the terminal on Mac or whatever? Well, all you do in Windows, if you just type explorer.exe it'll open up Explorer here, or better still, on either Mac or Linux or Windows. So regardless of what type of computer on, you can just type code dot, and it will pop up Visual Studio Code and open up your folder. And so then you can just go ahead and if you haven't used VS Code before, it's really well worth taking a few minutes to read some tutorials. It's a really great IDE. And so you can go ahead and create
Geek out time. Heck yeah. File. I've been waiting.
Like they tell you to, app.py file, containing what they told you to put in it. Here it is here. All right, we're nearly there. So you can now go ahead and save that.
I already committed and pushed, so
and then you need to commit it to Gradio. That's a Gradio, to Hugging Face Spaces. So one really easy way is just in Visual Studio itself, you can just click here, and that'll give you a place where you type a message and you hit tick, and it'll send it off to Hugging Face Spaces for you. So once you've done that, you can then go back to the exact same website you're on before, Hugging Face Spaces, JPHOO, minimal. And what you'll find now is that it'll take about a minute to build your website, and the website it's building is going to have a Gradio interface.
Okay, I need to give it some time, I guess.
With a text input, a text output, and it's going to run a function called greet on the input, and my function called greet will return hello name. So that's what it's going to do.
That's crazy.
Oh, there it goes. Let's try it.
Okay, beautiful. This is exactly what I needed. Like literally exactly the perfect
I'm not always
thing.
very good at remembering how to spell his name. I think it's like that. And there you go. So you can see it's put the output for our input. So not a very exciting app, but we now have, to be fair, an app running in production, right? Now, I told you we'd have a deep learning model running in production. So now we have to take the next step, which is to turn this into a deep learning model. All right, so first we're going to need a deep learning model. And there's a few different ways we can get ourselves a deep learning model. But basically we're going to have to train one. So I've got a couple of examples. I've got a Kaggle example and a Colab example. Maybe I'll quickly show you both. They're going to do the same thing. And I'm just going to create a dog or a cat classifier. Okay, so here's our Kaggle model. I'll click on edit so you can actually see what it looks like in edit view. Now, Kaggle already has fast.ai installed, but I always put this first, just to make sure we've got the latest version. And obviously import stuff. So we're going to grab the
It's the same example that we've been looking at.
Function to check whether it's a cat. That's our labeling function for our image data loaders. Remember, this is just another way of doing data blocks. It's like a little shorthand. And we create our learner, and we fine tune it. Okay, so that's all stuff we've seen before.
But we didn't do this part right here. Hold on. I'm going to copy that real quick. Well, maybe let me let him finish, and then I'll do it.
In Kaggle, every notebook has an edit view, which is what you just saw, and a reader view. And so you can share your notebook if you want to, and then anybody can read the reader view, as you see. And so you can see it shows you what happened when I ran it. And so I trained it. It took, so the GPUs on Kaggle are
I hope it trains
slower
faster
than most modern GPUs, but they're still fast enough. I mean, it takes 5 minutes. And there's one bit at the end here, which you haven't seen before, which is I go learn.export, and I give it a name. Now that's going to create a file containing our trained model. And that's the only thing. Creating this file is the only thing you need a GPU for, right? So you do that on Kaggle or on Colab. So here's exactly the same thing on Colab. You can see pip install is cat, untar data, image data loaders. So I've got a show batch here as well, just for fun. Create my learner and then export. So while we wait, I might go ahead and just run that. One nice thing about Kaggle is once you've run it and saved it, you can then go to the Data tab, and here is basically anything you've saved, it's going to appear here. And here it is, model.pickle. Right? So now I can go ahead and download that, and that will then be downloaded to my downloads folder. And then I need to copy it into the same directory that my Hugging Face Spaces app's in. Now, my Hugging Face Spaces app is currently open in my terminal. On Mac, you can type open dot, or in Windows, you can type explorer.exe dot, and that'll bring up your Finder or Explorer in that directory. And so then you can just paste that thing you downloaded into this directory. Something, by the way, in Windows I do, which I find really helpful, is I actually grab my my home directory in Linux, and I pin it to my quick access, and that way I can always jump in Windows straight to my Linux files.
I'm gonna let
Not
them
really something you have
finish
to
and then
worry
I'm
about
just
on
gonna run
Mac
through it
because
by
it's all
myself.
kind of integrated, but on Windows they're like kind of like two separate machines. Okay, so let's do. So I created a space called testing, and I downloaded my model.pickle and I pasted it into testing. So now we need to know, how do we do predictions on a saved model? So we've got a notebook for that. Okay, so we've got a notebook for that. And so I'm going to take you through how we use a model that we've trained to make predictions. There's a few funny things with hash pipe, which I'll explain in a moment. Just ignore those for now. So we import fast.ai as usual. We import Gradio, as we did before. And we copy in the exact same isCat definition we had before. That's important. Any external functions that you used in your labeling need to be included here as well, because that learner refers to those functions. Okay, it saves, that learner's saved everything about your model, but it doesn't have the source code to the function, so you need to keep those with you. So let's try running this. So for example, I just grabbed, as you might have seen in my Explorer, I just popped a dog picture there. And so we can create a Python image library image from that dog, turn it into a slightly smaller one so it doesn't overwhelm our whole screen, and there's a picture of a dog. So how do we make predictions of whether that's a dog or a cat? Well, it's very simple. All we do is, instead of training a learner, we use load learner. We pass in the file name that we saved, and that returns a learner. This learner is exactly the same as the learner you get when you finish training. So here we are, here's Colab, right? We've just been training a learner. So at the end of that, there's a learner that's been trained. And so we kind of froze it in time, something called a pickle file, which is a Python concept. It's like a frozen object. We saved it to disk, we transferred it to our computer, and we've now loaded it, and we've now unthought it. Here's our unpickled learner. And we can now do whatever we like with that. So one of the things that one of the methods that a learner has is a .predict method. So if I run it, you can see even on my laptop, it's basically instant. In fact, we can see how long it took. If you, in Jupyter, things that start with percent are called magics. They're special Jupyter things. So for example, there's a thing to see how long something takes. There you go. Okay, so it took 54 milliseconds to figure out that this is not a cat. So it's returning two things. Is it a cat as a string? Is it a cat as a 0 or 1? And then the probability that it's a dog and the probability that it's a cat. So the probability of 0, false, and 1, true, of is it a cat. So definitely a dog. So we now want to create a Gradio interface which basically has this information. So Gradio requires us to give it a function that it's going to call. So here's our function. So we're going to call predict, and that returns, as we said, three things. The prediction is a string, the index of that, and the probabilities of whether it's a dog or a cat. And what Gradio wants is it wants to get back a dictionary containing each of the possible categories, which in this case is dog or cat, and the probability of each one. So if you haven't done much Python before, a dict of a zip may be something you haven't seen. Very handy little idiom, well worth checking out. Ditto if you haven't seen map before. Anyway, here it is. One slightly annoying thing about Gradio at the moment is that it doesn't handle PyTorch tensors. You can see here PyTorch is not returning normal numbers, it's returning tensors. It's not even returning NumPy arrays. In fact, Gradio can't handle NumPy either, so we have to change everything just to a normal float. So that's all that this is doing, is changing each one to a float. So for example, if I now call classify image with our doggy image, we get back a dictionary of a dog. Yes, definitely cat, definitely not. So now we've got all that, we can go ahead and create a Gradio interface. So Gradio interface is something where we say, well, what function do you call to get the output? What is the input? In this case, we say, oh, the input is an image. And so check out the Gradio docs. It can be all kinds of things like a webcam picture or a text or, all kinds of things. Give it a shape that it's going to put it into. The output's just going to be a label. So we're going to create a very, very simple interface. And we can also provide some examples. And so there's a dog, a cat, and a dunno, which I'll tell you about in a moment, which you'll see here. There's a dog and a cat and a dunno. So once I launch it, it says, okay, that's now running on this URL. So if I open that up, you can see now we have, just like Suvash, we have our own, not yet in production, but running on our own box.
I guess that's a dog,
classified.
right?
So let's check. Dog. So you can click it and upload one or just choose the examples. There we are. So it's running on my own laptop, basically instant. And I really have to tell you the story about this guy here. This is the dunno. Submit. Wait, why is it saying 100? Normally this just says like 50-50. That's a bummer. This model's got messed up my whole story. So last time I trained this model and I ran it on the dunno, it said like almost exactly 50-50. And the way we found this picture is I showed my 6-year-old daughter. She was like, what are you doing, Dad? I was like, I'm coding. What are you coding? Oh, dog cat classifier. She checks it out and her first question is, can I take your keyboard for a moment? And she goes to Google and she's like, what is a dog mixed with a cat called? I'm like, there's no such thing as a dog mixed with a cat. Anyway, she goes to the images tab and finds this picture and she's like, look, there's a dog mixed with a cat. She said, run it on that, Dad, run it on that. And I ran it and it was like 50-50. It had no idea if it was a dog or a cat. Now this model I just retrained today, now it's sure it's a cat. So there you go. I think I used a slightly different training schedule or something, or I gave it an extra epoch. Anyway, so that's a dog cat, but apparently it's a cat. I guess it is a cat. It's probably right. Shouldn't have trained it for as long.
That looked like a dog.
So there's our interface. Now that's actually running, so you actually have to click the stop button to stop it running, so otherwise you won't be able to do anything else in your notebook. Okay. So now we have to turn that into a Python script. So one way to turn it into a Python script would be to copy and paste into a Python script all the things that you need. Would be to copy and paste into a Python script all the parts of this that you need. So for example, we wouldn't need this, it's just to check something out. We wouldn't need this, it was just experimenting. This was just experimenting. We'd need this, right? So what I did is I went through and I wrote hash pipe export at the top of each cell that contains information that I'm going to need in my final script. And then, so there are the steps, right? And then at the very bottom here, I've imported something called notebook to script from nbdev. And if I run that and pass in the name of this notebook, it creates a file for me called app.py containing that script. So this is a nice easy way to, like, when you're working with stuff that's expecting a script and not a notebook, like Hugging Face Spaces does, it's fine to just copy and paste into a text file if you like, but I really like this way of doing it because that way I can do all of my experimentation in a notebook, and when I'm done I just have a cell at the bottom, I just run and export it.
Notebook to
how
script.
does it know to call it app.py? That's because there's a special thing at the top, default export, default exp, which says what Python file name to create. So that's just a little trick that I use. So now we've got an app.py. We need to upload this to Gradio. How do we do that? You just push it to Git. So you can either do it with Visual Studio Code, or you can type git commit.
Stop doing that.
And then git push. And once you've done that, if we change minimal to testing, I think this hopefully might still be running my previous model because I didn't push it, and that way we can see our crazy dog cat. All right, so here it is. You can see it running in production. So now this is something that anybody can, if you set it to public, anybody can go here and check out your model. And so they can upload it. And so here's my doggy. Yep, definitely a dog. Cat. Yeah, I think I might have trained this for an epoch or two less, so it's less confident. Yeah, definitely a cat. Dog cat. Hey, dog cat. Still thinks it's definitely a cat. Oh well, so be it. Okay, so that is okay, so that is an example of getting a simple model in production. There's a couple of questions from the forum, from the community. Okay, so one person's asking, what's the difference between a PyTorch model and a fast.ai learner? Okay, that's fine. We will get to that shortly. Don't know if it'll be this lesson. It might be this lesson or the next lesson. And then somebody else asked, basically it's asking how many epochs do we train for? So as you train a model, your error rate, as you can see, it improves. And so the question is, should I run more? Should I increase the number of epochs? This is doing 3 epochs, right? Here's my 3 epochs plus 1 to get started. Look, it's up to you, right? I mean, this is here saying there's a 1% error. I'm okay with the 1% error. You know, if you want it to be better, then you could use more data augmentation and you could train it for longer. If you train for long enough, as we'll learn about soon in the maybe in the next lesson, if you train for long enough, your error rate actually starts getting worse. And you'll see, we'll learn about why. So basically, yeah, you can train until it's good enough, or until you run out of patience or time, or run out of compute, or until the error rate starts getting worse. Okay. Oh, and then in Colab, how do you grab your model? All you need to do in Colab is, after you've exported it, is if you go into their file browser, you'll actually see it here, right? And you can click download. It's a bit weird. It doesn't like pop up a box saying where do you want to download it to, but instead this kind of progress circle thing pops up, and so depending on how big it is and so forth, it can take a few minutes. And once that circle fills up, then the browser thing will finally pop up and say, okay, you can save it. Okay, so that's how you actually grab your model. So as you can see, the step where you actually need a GPU, you can use these totally free resources, Colab, Kaggle. There are other ones we'll talk about in future lessons. And then you can do everything else on your own computer, including the predictions. The predictions are fast, right? So you really don't need to use a GPU for that unless you're doing thousands of them. Okay, here we go. So now it's asking me to save it. Okay, so now one big issue is we needed, to run it on our computer, we needed Python and Jupyter notebooks running on our computer. So how do you do that? Because this is where often people get in all kinds of trouble trying to figure out how to get this all working. So the good news is we've actually got something that makes it very, very straightforward. It's called Fast Setup. There's really only just one part of it you need.
I don't know. I might have already did that.
It's actually
I already have
a
notebooks.
Git repository on GitHub. GitHub's the place where most Git repositories live. So if you go to GitHub fast.ai Fast Setup, you'll see it. And so what you can do is you can now grab this whole repository just by clicking here on code. And if you've got GitHub Desktop installed, click on Open with GitHub Desktop. And as you'll see, it brings this up saying, okay, I'm ready to save this for you. So I click Clone. So it's making a copy of it. There we go. So basically, once you've cloned it, you'll then find there's a file in there called setupconda.sh, which,
I
you
don't
know, the
have
details don't really matter. It's
Anaconda.
pretty short, but that's the thing that's going to install Python for you. So at that point, you can just run
Or maybe I do, I don't know.
./setupconda
But
and
all
it'll
my
run
Python stuff is already
this
set up
installer.
in
Now,
notebooks.
if you've got Linux or Mac, you've already got Python on your machine. Don't use that Python. And the reason is because that Python, it's called the system Python, it's used by your computer to do computery stuff, right? It's actually needed. You don't want to be messing with it. I promise you. Like,
And I have
it always leads to
virtual
some
environments
sort of
for my Python
you want your
installs.
own development version of Python. It's also going to make sure you've got the latest version and all the libraries you want. And by far the best one for you is almost certainly going to be these Conda-based Python distributions. So if you run setup Conda, you'll get the one that we recommend. And the one we recommend at the moment is something called MambaForge. So basically, once you run it, you'll find that you've now, and you close your terminal and reopen it, you'll find you've now got one extra command, which is called Mamba. And Mamba lets you install stuff. So once you've run it, you'll be able to go Mamba install.
I never heard
fast.ai.
anybody say Mamba.
And that's gonna actually I should mention there's actually bit more detail about how to install it correctly.
Okay, let's see. I promise I'm gonna let him finish, but first. All right, I wrote myself a couple notes, but I may have to review. So let's see if this is done. It's not done yet. Did I push it? Oh my. It never pushed. I need help, bro. What is wrong with me? This little pop-up came up and I never even responded to it. What? I don't know my password. What are you talking about? It's not my password. I think I have I think I log in with Google. What are you talking about? I don't know no passwords, man. Oh, that's annoying. Oh, apparently I have a password. Okay. I just don't know what it is. So let's figure how to. Y'all don't need to see all that. Let me figure out my password. Can I have a tab, please? Thank you. Thank you very much. That's so dumb. I actually have this same profile open on this other monitor. So that was a waste, but let me see. Okay, pretty sure that's exactly what I typed in, but oh no, I guess it's not. Okay, let's try to push again. Yay! Okay, so that was all that time. It was just sitting there waiting on me. What happened to my... Oh. Okay, so that's working. All right, so I created a space, I cloned it, I did create an app.py, and then I did git commit and push. Now I need to add the model by training it and exporting it. So let's see. Do I have Kaggle open? I wonder if Kaggle will train faster, because it's like he keeps talking about it's only supposed to take 5 minutes. Like my model was taking like an hour. Let's go here because I wonder. Can I see who? Yeah, I can see who I copied it from. He had code. Saving a basic fast AI model is the one that he showed. I think it was the second one too. I think it just said cats and dogs. This is all of them. Oh, you know what? The cats and dogs might have been in oh, is it? Oh, it's in this one. Okay. So let's copy it. I want to see if it'll train faster than my collab ones are training. Oh, I guess I do want it to fine tune. Sure. Well, that's the training actually. Yeah, so I need to let it do all that. And then here it'll export. It's pretty fast though. I wouldn't be surprised if Google like is kind of, you know, allowing the bottom of the barrel, so to speak, when it comes to the training speed or whatever hardware we have access to for the free plan in collabs. So okay, I'm going to need the exported model file, and then I will upload that to my my Hugging Space repo. So in the meantime, I do need the code that goes into the app file, and because that's the end of this, right? Yeah. It was another there was another notebook, but it might have been one of the book chapters. Scaling up, multi-target, blah blah blah. Let me see where he pulled that from. I think he pulled it from the and I'm at 5728. I think he pulled it from the book. Create an interface, create a Python script.
Okay, so
No, it was before this. Oh, it was a testing. What's called testing? Where do you get that from? Okay, apparently there was just something called testing. Let me see if I see one of those. Let's see what's on the web page. Here's the notebook for saving the model. It's probably in the chapter 2 notebook. They did bears in this one though. I'm about to have to write this code. Okay, that's fine. So let's do it like this. Go back. And then I need this one and this one. Okay. Can I get not 360p? Sometimes this music gets so slow. I'm like, I can't take it. It's like lullaby. All right, we go to our other playlist, y'all. I really want to at least get this part done. Let me see how the training is going. Oh, is it done? Oh, I didn't. I thought I had set to run this. Open the Kaggle sidebar on the right, and then find the section marked output. What? You. Mm. Mm-mm-mm-mm. Data. Wait, what? Oh, I see. I see. Wait, no. I'm confused. Oh, wait. Do I have to go back? Let's see if I have to go back. Okay. This one. That's not what I was trying to do. Oh, do I have to share it? Make it public? All right, that might actually do something. Mm-mm-mm-mm. All right. So starting from the top. Okay, so now that is possibly in progress. The other thing I need is to create the script. So let's do that. Mm. Think we at least need everything that has an export on it. So oops. From Oops. Now I got the Gradio import. And then we need def is cat x sub 0 dot is upper. And then what else do we need? Hello. Close. Oh my god, I was reading that. If I'm not mistaken, I downloaded like a cat picture the other day too that I was supposed to use to test this model. Learn equals load dot learner. Load learner. Okay. And then classify image. No, I don't need that one. But I do need this one. Image equals gradient. Inputs. My contacts are so dry. Oh my god. Shape equals 192. I think it was like cute cat or something. .jpg. I'll change it to whatever the name is. Okay, hold on. So after the classify image, define the image, label, examples, and then interface, Gradio interface, function, instead of the greet function, call the classify image. And then for inputs, image, outputs, label, examples equal examples. Okay, and then launch our interface. They put inline equal false, so I'm gonna add that. Is there anything else I need? Okay, so let me save this for now. Hello? No, not that. Trying to save this file. Let's go back to the model. Is this the page I was on? Here it is. Save and run all complete view. Data. Wait, what? Like he had a open the Kaggle sidebar, find the section marked output, open the Kaggle working folder. Here we go. Download. Okay, reading is fundamental. Let's see. Are you this smart? Oh shoot, I didn't want to do that. Are you this smart? Yes. Okay. So the model is there. Same name. Oh, I need a image. Let's go to Finder. No, that's not what I'm trying to do. Thank you. Finder. I was gonna say it should be one somewhere. Downloads. It was like cute cat pic or something like that. They added. Probably would have been last week though. Okay, I guess we will just grab a picture because I don't see the one that I downloaded. If I even downloaded it, maybe I didn't. Cats. I could swear I downloaded that picture. What is? Cat. Pic. Save. Move that one over here. It is a JPEG. Close that. Where is it? Cat pic. Oh, that says cute pic, which is literally not what I'm supposed to. Okay, there we go. I can't type. Alright, what else do I need? So I exported my model. I added it to my Gradio project. I added the image classification function and the is cat function. I think that's everything, right? Let's see how this space is working right now. Is it done? Oh, it's running on my local host. Or what? Copy. No, JK. Well, like Kaggle? I don't know. I need a URL. I am gonna have to run this Jupyter notebook that I'm writing right now locally though. Yeah, cause like okay, whatever. Oh, this is the logs anyway. I'm not supposed to be in the logs. I'm supposed to be here. What was it supposed to do in the original code? Oh, tell me hello. Okay, got it. Submit. Okay, that works. Now let's push our new code. Git status. Git add all the things. Commit. Adding. Let's see. Deploying. Image. Push. I think I got everything I needed. I think I did. Now, it's taking a second. That model must be slowing it down a little bit. What? Am I supposed to just run this locally? Did he not push it? I'm confused. Well, let's get back to here. Oh, it's just a Python project, so that's all I gotta do is run the Python app. Is this the only thing that's different about mine? I think if I'm not mistaken, on Kaggle I might have seen an option to add the model to the space, so I might have to do that one that way. It's kind of weird it's not letting me upload it that way though. Samples and INTF. No, my interface is called iFace. Save. Okay, and then yeah, that should be the general. Oh, it exports it as a notebook? Wait, do I need the notebook file too? Because I put all the code in there already. That's not right. Oh, here's a URL. Let's see what this says. Copy. Might be a setting I have to change or something. Configuration. Clone. CD. Setup. Do you have files larger than 10 megabytes? Those files should be tracked with git lfs. Git lfs install. Oh, so if I do that, then everything should work. Git lfs install. Okay, let's do that. Git lfs install. What? Is this supposed to be all one word? Let me see. I wonder if it's let's try, because that definitely does not work. Let's see. Git. Git dash LFS. Navigate and click download on your computer. Locate the downloaded file. Let's go to Mac. Navigate, click download. Or I can use Homebrew. Brew install Git LFS. And then go to step 6. Okay. So that was what page is that on? Can I see? I try to keep an eye. I try to keep a eye out for things that I would contribute back to documents. So okay, so Homebrew can install it for me. So brew install Git dash LFS. Brew install. I hope it don't take too long. It's updated. It usually doesn't take too long. The main thing I don't like about this terminal when I'm inside of VS Code is I can't see output in the top of the, like I would normally see in the top of my terminal window. Okay, so now let's run it. Now let's get push. And then, so this was if you have files over 10 megabits, but then there was another script as well if you have files over 5 gigabytes, I think it said. For now, I'm just gonna install this version. Why are you treating me like this? You can't tell me what to do. It's my repository. Oops. Let's go back one more time. Actually, let's do this real quick. Where's my regular terminal? Open a new one. All right, let me go back to what it was saying in the instructions. Navigate here. Nope, I use brew. Yeah, my install worked, right? When I ran git lfs install, yeah, it says it was installed. Maybe, let me see, git status, git add, oops. Mm, 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 mm. Offending files. So is this something else I didn't do? Do I have the Hugging Face CLI installed? I don't know. Let me see what's, where is it? Right here. Okay, so it doesn't take anything. Dismiss. Yeah, I'm gonna try something. Let me move it. I don't want to delete it. What was it called? Model 2. Oops. Is it individual files or is it the total? I wish I would have added those separately. Oh, that's annoying. Okay, let's do this because I want to Command A, Command C. I do want to see if this will work, and then I can worry about the getting the rest of the issues fixed later with the Git option. Create a upload a file. Here. Model open. What else? I need the cat pic too. That's weird that it was able to do that. Actually. Does this keep the reference to the file? Huh. So I have one there and it must be a copy instead of a move. Okay. Got those. All right, this is my workaround for right now. Especially since it's already after 2 and I should have been got this working. Well, I'm not going to say that because this is what happens when you think you could follow a demo from somebody's video. Okay, so that is uploaded and then I need to edit this file. Luckily, they have a UI similar to Git or similar to GitHub anyway. Okay, so now let's see what happens. It's gonna build. Oh, the module. Wait. I thought I had a. Dang, did I skip the installation for. Yeah, I think I skipped the part. Damn it. Damn it. Okay. Pretty sure. Let's see. This is saving the basic model. Yeah. I need this. Which is irritating that was even missing. Wait. I guess I wasn't using it before. Okay. I'm like, wait, why didn't it give me that error before? But I wasn't using it before. So let's add that to the... I have too many tabs open. Is it here? Yeah. Runtime error. Wait. Go back. Go back. Go back. Go back. Okay. So let's edit. Oops. Let's edit this file. Before all of this. Okay, let's try again. See how the log is doing this time. Y'all probably can't even see my log. Syntax error. Okay. Wait, let's go back and see. Hold on, because I actually need to... I can't even concentrate right now. I will be right back. Okay, because I literally couldn't even concentrate. I had to pee so bad. That was not saving me no time after a while. Okay, now I can focus. Yeah, there wasn't any code for... Unless I need that app.py. Or, the Python notebook. I don't understand why I would need the Python notebook. All right, let's look at the docs. Because I'm only gonna do this for so much longer. Get started. Create my files. I did all that. Gradio spaces. Here's a demo. Files. That's the model. They have some JSON files, readme. So, did I get an actual error? What's the? Yeah, just saying. Oh wait, let me see the formatting because that kind of looks like. Oh, I guess not. Wait, where am I? Right? Nope. Okay, so that's one example. Create requirements. Let me see. Because there ain't no requirements files in here. I guess that depends on what it's using. Config, readme. That's the model. JSON runs. I'm going to try it this way, even though I don't actually see the requirements file in the example that they're referring to. Oh, I get, yeah. Okay, I guess they just assume it's this is just the model. I understand now. So it's using that model. Okay. Okay, so let me just do a requirements and hopefully that will work by itself. Where am I going with it? Because let me see if his had a requirements file too. It might have it in there. It's like not even easy to tell because I don't think he actually shows the whole repository. No, yeah, the whole folder. Where was it at? Okay, back here. Yes, he does have a requirements file. Okay, that's fine. Alrighty, so this is the one. Oh no, that's not what I'm trying to do. Doing this from the UI. Okay, so we don't need that. Wait, let's see, can I do this? No, I can just edit. Get rid of that. All right, so I got rid of it there, and then inside of here, I need a requirements file. Oops, requirements dot txt, right? Yeah. And then I just need fast AI. Oops. I don't remember that happening, but I could have missed it. Okay, that's promising. So let's see. Yeah, it's up. It's changed now. So if I put this image, definitely a cat. Then if I upload, let's upload the lit llama. It says it's a dog. I guess it doesn't really have an option to compare it with, but that's fine. Okay, So, yay. That was a little bit more trouble than I was expecting, but all in all, not too bad, honestly, because at least it's working. And I need to figure out this issue why it's not accepting my Git LFS install, because it's definitely like it ran, but then it still wasn't letting me push my file. And I was only supposed to have to run the second command if my file was over 5 gigs, but you can see that here in my space, I think it was only 40, if I'm not mistaken. Files. Yeah, it was 47 megabits, so it should have been well within the range to be pushed. So I'm not sure why that wasn't taking, but I'm going to look into that and see how I can fix it. Actually, what I want to do before I finish it off is I thought I set this. Git config. Well, maybe it's using some, I don't know. Git config pull dot rebase. True. All right, let's resolve our conflicts. Where just the model. It's not really a conflict though. Let's do this. Git status. Interactive rebase. Last command done. Next commands to do. You are currently rebasing. Fix conflicts and then run git rebase -- continue. Let's just go with git add model. I hope it's not showing some type of difference in the model. They should be exactly the same. Git rebase -- continue. Oh, open anyway, I guess. I don't think I'm gonna be able to open it though. Okay, so more complications. That's fine. It's fine. It's all fine. What? Unusual line terminators? Where's that coming from? I really just wanted to see if somehow, like, because Git is complaining, but if it's really a big deal, I would have expected to see it, like, maybe improperly inserted the little tags it uses to show the differences when you do when you have a merge conflict, but I don't see anything like that. So yeah, I'm just gonna stick with what I have now, just because my model is deployed and running. I can force pull git force. First of all, Get reset dash dash hard. Already, let me see. So that doesn't. Oh, reset back to a specific commit. Okay. Get reset dash dash hard. Then my commit hash. Wait, first of all, get rebase dash dash abort. Wow, I didn't spell that right. It's okay. Okay. Get rebase. Oh, I can't see the log no more. Log. So I guess I'm resetting it back to this hash, right? Add the application file. I think that's where they diverge. Oh no. This command removes the specified commit and all subsequent. So I wanna wait, should I? No. I think that one should already be in the history. So I need the next one. Let me check my commit history. Add application file. Yeah. So I want to keep that one and delete the one that's after it, which is this one. It definitely said that it would delete that one. So git reset. Commit hash. Oh, it kept it. Even though technically that one probably actually works because it was me deleting the model that was the change that couldn't be applied. I probably could have skipped it too, but whatevs. Okay, reset that. And then when I pull, I don't need to push, I just need to pull, get pull origin. I should just be able to pull regularly now though, right? Yeah, okay. So at least I cleaned it up. But here, I should write myself a note because we fix issue with get LFS not working for 41 megabyte model upload on Git push. Alrighty. So that makes me feel good. That's another little check mark I can kind of lean on and be proud of. Oops, sorry. So now what I'll do is tomorrow I'm going to finish the video because it was like probably 20-30 more minutes left, but I was just eager to get something going. So yeah, I'm going to pick back up where I left off with that tomorrow. And it should, I want to see about connecting these. Can I set another remote on this code base? I wonder. I never did that before, but I feel like I should be able to do that, right? Like push to GitHub and push to spaces at the same time. Okay, so get remote add origin. It's one URL. Let me see how they're naming it right now. Get remote. Yeah, that's right. Yeah, they're called origin. Okay. So let's do this. Let's go to GitHub. It's called MDG. It's not really like should be called MDG, right? All right, so I'm just gonna make a blank repo so that I have a remote. But I'm gonna call it do I have, yeah, it's the main branch. Okay, so I'm gonna do all of this except get remote add. I'm gonna, instead of calling it origin, I guess I'm gonna call it GitHub. Get remote add GitHub. I just realized I'm not using the SSH on Hugging Face right now. Get branch dash M. which is already here. That's already set. Git push dash u GitHub main. Yeah. I hope that works. I forgot about the LFS part that fast. It does say uploading LFS objects though. If it works pushing it to GitHub but just not pushing it to Hugging Spaces, then it might be worth me still going through and doing the Hugging Face CLI integration or update or installation, whatever it was asking for, because even though the file's not over 5 gigs, shouldn't be a reason why it works fine for GitHub and it doesn't work for the other one. Beautiful. Yay. I feel really good now. The other thing is, probably for more of my own sake, let's go here, Command C, and then let's add this URL here. Save. Yay. Okay. I feel like I actually accomplished something. All right. So I'm gonna call that a night at this point, and I'm gonna pick back up tomorrow. But now that I have all that figured out, again, I am gonna finish the last little bit of the video, and then I'm going to start going through the book material. I don't imagine it to be as it might be. I don't imagine it to be as much or take as long as it took me to finish the first chapter, just because most of it was the setup and I think I kind of got the gist of it. But I am still going to read through the book because I think they add more context and more information and everything. So and then after that, that means I'm all good to work on some projects. So that was the first one. Actually, the cat the image classifier was like the first one I was supposed to work on. So now that I have a basic model deployed, I can go ahead and improve my model or redeploy a new model and kind of spruce up that example. Yeah. So that shouldn't take too long. So I'll just work on some projects for the rest of the days. Like if this is me catching up with my original schedule, that's good, because it took me a week and a half to finish the first lesson. But I also spent like 2 days watching Congress hearings, so it's fair. But yeah, I appreciate everybody for being here and supporting, and wish you all continued success and motivation for those of us that are on 100 Days of Code right now. So I'm gonna go ahead and sign off, and I will see y'all tomorrow.